All right, here we go. This is day 2 of series, and we're going to do GST, nth, and telescoping. And we need some readers up in here, and Doug's going to start. Here we go.
A series is the sum of the terms in a sequence. Finite sequences and series have defined first and last terms, whereas infinite sequences and series continue
Indefinitely.
A series is informally the result of adding any number of terms from a sequence together. A1 plus A2 plus A3, so on. A series can be written more
Succinctly. You're doing great.
Summation, symbol, sigma, the Greek letter x for each sum. The E is both silent and not really there.
Good.
For infinite series, we can look at the series of partial sums. That is, looking to see what the sums are doing as we add additional terms. In general, the nth partial sum of a series is denoted S of n. This can be explored on a calculator by adding sequential terms to the aggregate.
Good. All right, I'm going. For both a sub n is equal to 1 over n and b sub n is equal to 1 over n squared, we're going to generate the sequence of partial sums. So let's do it. So let's deal with this a sub n first. So what is my s sub 1? We substitute in 1. What do we get? 1. All right, I only have one term going on, so now we're going to find s sub 2. Well, s sub 2 would equal 1 plus, now I'm going to substitute in 2 for my a sub 2. So what do I get now? 1/2. So now I add them together and I get 3/2. All right, and then we're going to find s sub 3. So it'd be the 1 plus 1/2, which is already what? 3/2. And then we're going to add to what? 1/3. And what would I get there? Let's do some common denominators. What would we get there? 11 over 6. All right. And then I would do s sub n and so forth. Well, s sub n, that's what we're going to be talking about now. It'd be a summation from 1 to infinity of this 1 over n. And we'd start adding all of them up. Well, what's happening as we're adding these up? If I go from 1 to 3/2 to 11/6, what happens to this? It's growing really big. Agreed? If it grows really big and they don't stop adding up, what do we know about this summation? It diverges. It diverges. All right? And we didn't prove it all the way yet, but I think with more examples today, we'll see that this is going to diverge. All right, let's look at this next one. So now, I now have 1 over n squared. So what's my s sub 1? Still 1. Then what's my s sub 2? 1 plus 1/4, which is how much? 5/4. And then what's my s sub 3? 5/4 plus 1/9, which is 49 over 36. Very good. All right. And now we're going to find my s sub n. And so my s sub n is really the summation from 1 to infinity of this 1 over n squared. And we don't necessarily know exactly what it is right now, but what do we think it does? This converges. Now, I want to talk about, does the result really surprise you? Why doesn't it surprise us? If this diverges and this converges, why will that not really surprise us? When have we seen this before? This is a p integral. All right? And we're actually going to call these a p series real soon. All right? If you remember correctly in 8.8, sometimes I called them p series, and this is why. All right? All right, cool. We're moving. All right, here we go. So let's look at this next example. So in this example, we have 3 over n, or 3 over 2 to the power of n. Now, on this problem, I personally would rewrite this. So I personally would bring out my 3, and then I actually have a what? A 1/2 to the power of n. On that problem, I think this is easier to work with it that way. All right. just like what we talked about with that 5/6 to the n, sometimes rewriting it will really help us out. All right, so here we go. So we're going to find the sum of the first 10 terms of these, but I'm not going to find them all because that's just crazy. So let's do S sub 1. What is my S sub 1? 3/2. All right, and then S sub 2 would equal the 3/2 plus the 3/4. So what do we get there? 9/4. We get 9/4. And then my S sub 3, I would add 3/8 to the 9/4. So let's double the 9/4. So I get what? 18/8. And then I add 3 to it. So what do I get? 21/8. All right. And then I would get S sub 4, which would be equal to, double it, add 3. Okay, double 21, what do we get? 42. So then we add 3 to it, we get 45/16. Do we see the pattern? I hope we do. All right, and then S sub 5, let's do it 2 more times. Let's do it 2 more times. Then we get 93/32. And then S sub 6, we get what? 189/64. And then we end up with S sub 7, which would be equal to even bigger. All right. We double it. 381 over 128. Now, you could keep on going forever and ever, but I want to do the summation from 1 to infinity of, I'm going to convert it to this way. All right. Now, what are these numbers looking like they're going towards? If I divide 381 by 128, go ahead and do it in your calculator. It's about what? It's about, it's not going to be over 3. But it goes to what? It's going to get closer and closer to 3. So this is actually converges to what? To 3. And we'll talk about why this actually happens real soon. All right. All right, cool. Let's look at the next problem. All right. So on this one, now we have 3/2 raised to the power of n. All right. So we're going to find the first 5 terms that are listed there, and then we're going to find the partial sums. So let's do S sub 1. So what does S sub 1 give me? 3/2. And then what's my S sub 2? 15/4. Good. All right. And then what's my S sub 3? 57, right? 57/8. And then what's my S sub 4? Let's double it and add 81. So 57 times 2 is 114 plus 81. 195/16. And then S sub 5. I'm just going to give it to you. I think it's this, 633/32. But now we're going to try to find a summation from 1 to infinity of 3/2 raised to the n. What's happening with these things?
It's going to 2.
It's going to 2?
No, it's getting
So 633/32, you think that's close to 2?
It's diverging because the n side is bigger than 1.
It goes to what? Infinity. So this means it diverges to infinity. All right. Because it's getting bigger and bigger and bigger. So let's look and see why. This is a geometric series. All right. And if it's in the term of this a times r to the power of n, where r is your ratio, that's what's being multiplied each time. Do You guys remember this in pre-calc or algebra 2 because it was in both. If your absolute value of r is greater than or equal to 1, your series diverges. However, if that is less than 1, then it does what? It converges. And this is that thing we're going to use again and again this year. So please circle that, do something, star it. So your summation to infinity is a sub 1 over 1 minus r. This is actually a big deal with series. In series, we don't normally know the summation to infinity unless it's one of two things we're doing today. All right, there's only two ways to actually find a summation to infinity, and we're going to talk about both of them today. All right, so one of them is GST, so it's a sub 1 over 1 minus r. So let's look at it. So let's look at example 8. We kind of did this one already. So we have a summation from 1 to infinity of 3 over 2 to the n. All right. I personally would kind of manipulate doing this. I'd say it's a summation with 3, and then I have 1/2 to the power of n. Do you see how that works? All right. I personally want you to rewrite those. So what is my ratio? 1/2. So is that going to converge or diverge? That's going to converge. So this converges why? I only have one gang sign right now. Converges why?
GST.
By GST. All right. We're going to have lots of gang signs by the time this ends. All right. But this converges by GST. You're totally gangster. I know it, Tom. All right. So that converges by GST, and we actually know what it converges to. So now I'm going to find my summation. And how do I find my summation with this one?
3 halves over 1/2.
All right. So we start out with 3 halves. Why do we start out with 3 halves?
That's your A.
That's my a sub 1 because I'm starting at 1. All right. And then it's over 1 minus my r of 1/2. Well, we have 3 halves over what? 1/2, which is how much? We get 3. All right. So that series actually converges to 3. All right. Let's look at part B now. So on part B, what do we got? Diverges. It diverges why? By GST. That's our gang sign. And then if I had to prove it, why? What do we know? 3 halves is what? Greater than 1. All right, 3 halves greater than 1. It diverges by GST. All right, let's look at this next one. So now I have a summation from 2 to infinity of 3 times negative 1/2 raised to the power of n. Well, is this set up an a times r to the power of n thing? Yes, totally. All right. So what do we know? It converges. All right. This converges why? By GST. All right. So how do we do this? We need to find my a sub 1, so my s to infinity. What do I substitute in now? I substitute in 2. So if I substitute in 2, negative 1/2 raised to the power of 2 is what? 1/4. 1/4 times 3 is 3/4. So now I have 3/4 over 1 minus, what is my r in this case? Negative 1/2. All right. So now I end up having 3/4 over how much? 3 halves. Well, dividing by 3 halves is really multiplying by 2/3. So what do I end up getting? 1/2. All right. So that series actually converges to 1/2. All right. Pretty cool. All right. We're moving. All right. All right. This is the nth test for what? Divergence. Only. All right. We'll talk about this. All right. So this is what it states. If we have a limit to infinity of our rule and it doesn't equal 0, that series diverges. Okay? So if my limit does not equal 0, then the series diverges. Does this say if my limit does equal 0, my series converges? No. Okay? This only is a limit is equal to 0 If it doesn't equal 0, the series diverges. All right, so this is an nth test for divergence only. All right, so it does not say it converges. All right, we have to use another test. All right, however, we use this first for everything. All right, because if it diverges, guess what? We done. All right, we don't have to keep going. All right, let's put it into practice. Here we go. So now I have these guys, and I need to figure out if the series converges or diverges, and we need to say why, and if we can find it some, we're going to find it some. All right. All right, so let's look at this one. I have 2 to the n plus 3 over 3 to the n minus 5. Well, what test could I use? I could use the nth term test. All right. So what's my limit as n approaches infinity of this thing? 2/3. Is that 0? No. So what do we know? Diverges by what? By nth. All right. It diverges by nth. All right. You don't have to say the nth test for divergence. We can just say it's nth. All right. All right. So that diverges by nth. All right. Let's look at this next one. So now I have n factorial over 2 n factorial plus 1. And that is 2 times n factorial. Okay. So if I take a limit to infinity of this thingy, what happens? I get 1/2. So what do we know? It diverges by nth. All right. Because my n factorials, they cancel, so I'm left with 1 over 2. All right. All right, this next one. I have 3 to the power of n minus 2 over 3 to the power of n. Are these things growing at the same speed? Yes. All right. So what do you know? What's my limit as n approaches infinity? 1. So what do we know? It diverges by nth. All right, let's look at part D. It doesn't. All right, let's look at part D. So now, if I take a limit as n approaches infinity, what do we know? It goes to 0. So does that mean it converges by nth? No. So now we have to use another test. And guess what? The only other test we know right now. Maybe it's a GST. So if I were to rewrite this, I could think of it as like a 1 over 1.1 raised to the power n. True? I go from n equals 2 to infinity. So what do you know? It converges why? It converges by GST. All right? It converges by GST because why? 1 over 1.1. 1 over 1.1 is actually less than what? 1. All right, so 1 over 1.1 is less than 1. It converges by GST. All right, you don't technically need this statement unless you really need to write it out. Okay, but normally you don't need that. Now, we can actually find the sum of a GST. Can't we? Yes. All right, so let's do it. So I'm going to find my s to infinity. So where do we substitute in to find my first term?
2.
We substitute in 2. So now I have 1 over what?
1.0.
1 no. What's 11 squared? 121, right? So it's 1.21 over 1 minus what? 1 over 1.1, because that's my ratio. All right, 1 over 1.1 is my ratio. All right, so now we got to do some math up in her. All right, what's my common denominator? 1.1, right? So I think of this 1 as what? 1.1 over 1.1. So now I end up with this 1 over 1.21 over, what do I got going on my bottom? 0.1 over 1.1. And then we want to do what with it? Multiply by its reciprocal. And so then we end up with 1.1 over
0.12.
1.1 over 1. 0.121. All right. Hitting, I think it's 100 over 11. All right. All right, pretty good? Cool. We're moving. All right, so right now we know 2 tests, right? You should always start out with nth test for divergence. If the nth does not go to 0, what does it do? It diverges. All right. If it does go to 0, then we have to use another test. Okay? Agreed? All right. And then if it's a GST, it's in the format of a sub 1 and then r to the power of n. And then how can we actually find it? If r is the absolute value less than 1, it converges. If it doesn't, it does what? Diverges. All right. And so now we're on to the telescoping series. So I need a good reader. Doug, pick a reader.
A series such as 1 minus 1 over 2 plus 1 over 2 minus 1/3 plus 1/3 minus 1/4 plus so on is called a telescoping series because it collapses to one term or just a few terms. If a series collapses to a finite sum, then it converges by the telescoping series test.
All right, fantastic. So if you look at these, this 1/2 and these negative 1/2 cancel. See how that works? And then the 1/3 and the negative 1/3, they cancel, right? But this 1/4, is it going to cancel?
Yeah. I'm gonna guess.
I'm going to guess yes. However, did it cancel? No. So we're actually going to need to take a limit to infinity of that last term. But 99.9% of the time, guess what that thing goes to?
0.
It goes to 0. All right? 99.9% of the time. All right? Unless it's an arctangent. We'll talk about that one way down the road. All right? All right. So let's look at this guy. So now we have a limit. I'm just kidding. A summation from 1 to infinity of this thing. So on this one, we need to kind of go term by term. All right? So let's start substituting in. We substitute in 1. What do we get? 1/3. And then what? Minus 1/5. And then plus, I now substitute in my next term. We need to start looking for this pattern. Now I substitute in my next term. What do I get? 1/5. And then minus 1/7. And then plus, I need to start looking for my pattern. What do I get? 1/7 minus 1/9. Have we seen the pattern yet? I think we have. So my 1/5 cancel. My 1/7 cancel. My 1/9 is going to cancel on this next term. Do you agree? Okay. And so now this is what we'd have. What are we left with? We're left with 1/3. But I need to add, or really I need to subtract my limit to infinity of my last term that's not canceling. So I have 1 over 2n plus 1, and I have 1 over 2n plus 3. What's the part that's not canceling? The 1 over 2n plus 3 isn't canceling. Are you following me? So I want to take a limit to infinity of that term that's not actually canceling yet. All right? So now, what is my limit to infinity of that thing? 0. So now I end up having 1/3, which means it converges to 1/3 by, I like to call it scoping. Telescoping. All right? You can pronounce it either way you want. I've heard telescoping and I've heard telescoping. I'm a scoping fan. All right? All right. All right, let's look at this next one. So now I have 1 over n times n plus 1. If I take a limit to infinity, what do I get? I get 0. So are we still good there? Yes. So my nth test for divergence, it didn't prove anything. So now I need to do something else. What do we need to do on this thing? If I start substituting numbers, are things going to cancel? No. There it is. All right, we got to do partial fractions. Here we go. So now I have a over n plus b over n plus 1. All right. So now I end up having a times n plus 1 plus b times n is equal to how much? 1. I like to cancel out b's to solve for a first. So what do I substitute in? 0. So what does A equal? A equals 1. And now I'm going to substitute in what? Negative 1. That cancels out my A. So what's my B equal? Love it. All right. And then we're going to back substitute. So now my summation, I end up having 1 over n and then minus 1 over n plus 1. You see how we converted using partial fractions? And technically, I should have parentheses around that. Why technically should I have parentheses around that?
Because it's going to both the summation.
Okay, because it's not the summation of 1 over n, it's the summation of 1 over n minus 1 over n plus 1. All right? All right, cool. So now I need to start listing term by term. So what's my first term? 1 minus 1 half. Then plus, what's my second term? We're going to do one more just to prove it. Then we get what? 1/3 minus 1/4. Honestly, I could kind of think about proving it on that second term, but anyway. All right, so now what didn't cancel? 1. 1 didn't cancel. All right, so then I have 1 minus. Now, the last term didn't cancel either, did it? So I technically need a limit as n approaches infinity of this 1 over n plus 1. And what does that go to? 0. 99.9% of the time it will go to 0. But it converges to 1 by what? Telescoping. This next one. If I take a limit to infinity, what's it go to? 0. So does nth test for divergence do anything for me? No. So I need to go another way. Is it GST? No, dog. So what are we going to do to this thing? We're going to factor it. So what's it factor to? N plus 3, n plus 1. Sounds good. All right. So what we going to do now? A over what? Plus. All right. So now I have 1 is equal to A times n plus 1, and then plus B times. Love it. All right. So now, let's cancel B. So I substitute in what? Negative 3. What does A equal? All right. So then B, I'm substituting in what? Negative 1. So B equals what? 1/2. All right. So let's rewrite it now. So now I have a summation from n equals 1 to infinity of, I'm personally going to say it's negative 1 over 2 times n plus 3. Sound good? Okay, can you do the negative 1 over 2 thing? Like negative 1/2 over n plus 3, can you do that? Yes, however, I think this makes easier because am I taking an antiderivative like we did partial fractions before? No. We're actually using it this time, all right? Before it would just be a nice natural log. And then we have plus 1 over 2 times n plus 1. All right, pretty good. And technically, I need a parenthesis around that. All right. All right. Well, let's start doing term by term. What's my first term? Negative 1 over 8 plus 1/4. Plus, what's my next term? Negative 1/10 plus 1/6. Man, nothing's canceled so far. Oof. All right, let's do another one. Then what? I'm feeling good about this one. Negative 1/12, and then plus, say it, 1/8. All right. Have we seen it yet? What canceled? The 1/8. What's not going to cancel? 1/4. And what else? 1/6. Is 1/4 and 1/6 ever going to get canceled? No. Is the 1/10 going to get canceled?
I hope so.
It will. all right? Because the next term, it's going to be negative 1/14 and 1/10, all right? So then the 1/10s are canceling. You following me? So now what's left? I have what? 1/4 plus what? 1/6. And then I'm going to subtract out my limit as n approaches infinity of what term isn't canceling for us. It's this first one, right? So now I'd end up with what? 1 over 2 times n plus 3. And what does that go to? What's a negative? What's not negative?
Is it negative?
Oh, I put it minus on there. All right, I love whispering. All right, so then what does that limit go to? Goes to 0. Good, 0. All right, so now what does it converge to? 1/4 plus 1/6. Now, could you actually do the math on it? Yes, you sure could. All right, and if you did the math on it, what'd you get, Harshna? 5/12. I agree. By telescoping. All right. Pretty good. All right. So, nth, go to 0, see if it works or not. If it does, you got to do something else. If it doesn't, diverges by nth. All right. GST, make sure it's in that correct form. Telescoping, go term by term, see them cancel. All right. However, what a lot of the times we'll go with telescoping? Partial fractions. All right. All right. There you go. There you go.